Okay, this is the test setup for our hydraulic water wheel experiment. You can see in the video, if you look carefully, the water wheel is attached to a small gearbox, which the blades are essentially square sheet, metal sheeting. And if you look carefully, you can see the jet coming, hitting the blades, and then once it comes out on the other side, the water's spraying out at an angle, and that's because they're straight bladed plates for the buckets, and that means that they're not as efficient as they could be, but at least it's working. The bottom line is that we have about a meter, it's just under a meter column of water being recirculated from this fish tank by means of a 0.16 horsepower pump that we did elaborate calculations on and got exactly what we needed. And if you believe that, you're stupider than I think I am. And anyway, the thing is, it holds the water level at just about 3 feet or 0.9 meters. This was Paymon's idea for a tank, which I think has worked beautifully. It has the advantage that the students can see that there's a column of water, which is creating the column height, which is creating the jet. The water's coming out, according to calculations, Bernoulli's law, at 4.23 meters a second. I did a rough calculation, or attempt to calculate the velocity on the assumption that the jet comes out horizontally and falls by a certain distance. And so it travels at constant speed horizontally, but falls in free fall. And I got a calculated velocity of near 6 meters a second. But in fact, if you look carefully, the jet is actually pointed slightly upwards at its emergence, and that would explain the difference. But the whole setup seems to be working neatly. One of the problems is that we'll have to give the students precise instructions on the width of the impeller and the buckets. But I think our current plans are to give them, to have them manufacture the little gearbox that you can see there, which is about 40 to 1. The gearbox has a little DC motor that's acting as a generator. We've checked it, not checked that particular voltage, but checked that particular setup, but it produces a voltage which we hope to be able to measure across a resistance, giving us an index of performance. The students will have the option of choosing 2 gear speeds, 2 gear ratio speeds. They'll also blade geometry and maybe the location of where they hit the jet. But it looks like, to sum it up, the whole project's a go. It looks like we've lucked out thanks to Paymon's fish tank and his idea for using these water bottles that he's carefully assembled into a column.
Yeah, just want to add some more notes. Benson was also here yesterday, so he gave us a hand to build the structure around the bottles to keep it steady so that they don't collapse. Thank you, Benson. Thank you, Phil. Good work.
I'm just relieved that it's working.
Yeah.
I'm just so relieved that it's actually working.
That's right. That's right. It's looking good. So we're going to bring it over tonight and show it to the rest of the team.